Hello again, everybody. I know last week we touched upon how if statements work, which is the basics of our conditional logic and conditional branching. Today we're going to take it a little bit further. We're going to learn about if else, if what's called if else if statements, and then also an intro to what's called a switch statement. So I remember last week we were looking at the example where somebody was going to either have a passing or a failing grade or passing or non-passing grade. I'm going to show you another way that we can implement something like that using, instead of just an if statement, what's going to be called what's referred to as an if-else statement, which is another type of binary conditional type of statement. So this is the general premise. Imagine you have a good FICO score. If you have a good FICO score and you're going to get a loan on a car or whatever, you get a good interest rate. If you don't have a good FICO score, you don't get a good interest rate. So we're going to put a little bit of logic in our program to do those types of tests. So let's imagine there's two types of levels. One would be the silver rate, and one is going to be the gold rate. And again, obviously, the better your FICO score is, the better your interest rate is on your loan, whether it's a car loan or a mortgage, whatever it might be. So let me put some constants in here. So here I'm going to have const double. Let's call this the silver rate, and we'll have the other one. We'll call it the gold rate. Let me initialize these to some values. So silver rate is going to be equal to the 6%, and the silver rate is going to be 6%, and gold rate is going to be the 5%. All right, so there's our constants. Let's create another local variable, which is going to be the level, which is if we exceed a certain threshold, we get the better rate. If we don't exceed that threshold, we get the not the better rate, or the other rate. So here I'm going to have another variable. It's going to be const int, and I'm going to call this the level, and I'm going to make this 650. Right? So the idea is that if you have a FICO score that's greater than or equal to 650, you get the gold rate. If your FICO score is less than 650, you get the silver rate, which is higher. Right? The idea is if you're taking out a loan, you want the lowest rate possible. And let's imagine that this is part of a larger system, and your FICO score is coming in from some third party, which is how it would be, which is like through a credit rating agency or something like that. And imagine our system here then captures your FICO score. So I'm going to create another local variable here. I'm going to call it int my FICO. Right? By the way, FICO is just the notion of your credit score. So that's the shorthand for what's called your credit score. It's just called your FICO score. So let's imagine your FICO score happens to be 400. Okay, so it's on the low side. So you wouldn't get the good rate, you'd get the silver rate. And let's create another local variable here, which is what we're going to use to store your interest rate. Right? So that's the upfront work. Right? Now what we're going to do is we're going to create a what's called an if-else statement here. All right, which will assign us one of two different values. Okay, that value is going to be either the silver rate or the gold rate, depending upon the condition of your FICO score. So this is no different than like what we saw last week. So here I'm just going to say if, let's say my FICO, if that's greater than or equal to the 650, which is the level, okay, then you're going to get the good rate. Okay, I'm sorry, if it's greater than or equal to that threshold, you're going to get the good rate. So here we're going to assign my rate is going to be equal to the gold rate. This is a binary outcome. So either you're going to have a good FICO score or you're not going to have a good FICO score. So what we can do here is we can then go ahead and use the notion of an else statement. So if the first statement is, or the first expression is not true, then this else, what's called the else, will execute. So this is going to be my else statement. And here I'm just going to say my rate is equal to the silver rate. So one of these two branches of execution will have to execute. So either line number 12 or line number 15 will be guaranteed to execute. One or both, one or the other, but not both. So in this case here, which is the one that's going to execute, it's going to be the line number 15 because my FICO score is 400, which means that I don't get the good rate. So let's go here and just display what your FICO scores. So see out my FICO score equals this. And let's also obviously display your rate, and my rate equals, and let's display what your interest rate is going to be, my rate. Oops. All right. So again, in this case here, my interest rate is going to be the silver rate, which is going to be the 6%. So if I execute this thing right now, you'll see that based upon my FICO score of 400, I get an interest rate of 6%. If I get a better FICO score, so let's imagine that this is now, well, let's make it exactly 650, right? Because at 650, that's the threshold where I'm testing for it being greater than or equal to the 650. So if my FICO score is exactly 650 or greater, I will get the better rate, which is going to be the 5%, right? This is the better rate. So let me do Control F5 here, execute this thing, and now you can see that now based upon my FICO score, I now get the better interest rate. So that's how an if-else statement works. Okay, so in order for you to have an else statement, you must have a corresponding if statement. You can't have an else statement without the if. So just imagine that this is paired with this. Okay, and the other thing too is you notice here that I use these curly braces. Technically, I could have left these off. The reason is because since I only have one statement paired with my if statement, I don't necessarily need those curly braces, but you'll notice that more often than not, you'll use if the curly braces, and so do I, and so will you see other programs and other examples, because it just makes your code a bit easier to read, and it's less likely you'll introduce bugs later on. So that's how an if-else statement works. Now that we know how an if statement works and we're able to make binary conditional, create binary conditional logic, what happens if we need to go ahead and execute something based upon, or maybe take multiple branches, meaning more than 2 branches? In that case, there's a couple ways to do that. The first way we're going to introduce it to you is what's called the nested if statement. And the way the nested if statement works is that you can nest your logic within multiple if statements to basically create more than two branches of output. So imagine this is the case here where, based upon a certain FICO level, you will get either a really low rate, a medium rate, or a high rate. Okay, so let's call them silver, gold, and platinum. So there's 3 different branches of execution that we could take, not 2. So let me go back into my code here, and let's change or amend my code here to add 1 additional rate, and we'll create a higher one here. We'll call this platinum rate, and we'll assign that 4%. All right. So the idea is that based upon your FICO score, you're going to get either a silver rate, gold rate, or a platinum rate. So again, there's 3 different branches of logic. And now what we're going to need to do is we're going to need to have more than 1 level to test against. So let's change this to be let's call this just the base level, okay? Meaning that if you get below the base level, you get the silver rate. If you get above the base level, then you're going to get either the gold or the platinum rate. So let's create another level here. So we'll call this platinum level. And in order to get the platinum level, you need to have a FICO score of 850 or better. All right, so here's a general idea. So if you get less than 650, you get the silver rate. If you get greater than 650, you're going to get either the gold rate or the excuse me, you're going to get either the gold rate or you're going to get the platinum rate. So let me put my FICO score to be. Let's just leave it at. I'm gonna just for now. Let me just change it to be. Well, let me just make it 700 for the time being. All right. Here I get some red squiggly lines. Why? Because I no longer have a variable that's called level. But this is where I'm going to introduce my adder nested if statement. So here I'm going to say if my FICO level is greater than the base level. So I'm going to say if my FICO level is greater than the base level, I'm going to do one of two different things within my if statement here, right? So if you're greater than the base level, you're going to get either the platinum rate or you're going to get the gold rate. So within this if statement, I'm going to nest an additional if statement. And the way this will work is I'm just going to say if my FICO, we'll do greater than or equals to again, is greater than or equal to the platinum level, and I'm going to use, so if they're greater than a platinum level, then my rate is going to be equal to the platinum. Platinum, did I spell platinum? Platinum rate. All right. So if the FICO score is greater than or equal to the platinum level, then their rate is, or my rate is going to be equal to the platinum rate. Else, and here I'm going to create my if else statement, and let me just move this curly brace down here. All right. If, here's some comments just so you can see where my if statements end. Well, actually this is else. I'll just make this rather verbose just so it's easy for you guys to follow along. All right. So here's how our logic is going to work. So now we actually have three different branches of execution that we could take, and the branches of execution are going to be land you on either line 13, 16, or 20. So here if the FICO score is greater than a base level, all right, meaning that it's greater than a 650, then we're going to branch into here and we're going to do another test. All right, so here we're going to test, okay, if their FICO score is greater than or equal to the platinum level, then we're going to assign the platinum rate to my rate. Else, they're going to be assigned the gold rate. So the idea is that once you get into this, once you successfully get into this branch of logic, then one of two things has to happen. You either are going to get the platinum rate or you're going to get the gold rate. If this turns out to be false in the beginning, so if this evaluates to be false, then what will happen is execution won't jump into this bunch of logic here. Execution will jump into this else statement. Okay, so if on line 11, if that expression is false, then we're going to jump down and execute line number 20. So in this case here, we actually have three different branches of execution. You know what? Let's test it for. You know what? Let's just start at the bottom. All right. So let's give them a 600 FICO score. Then I'll give them a 700, and then I'll give them like a 900, and you'll see that they'll get the different rates. So at first, when their FICO score is equal to 600, they should then be assigned the silver rate, which is on line 20 here. Right, so there they get the silver rate, which is the 6%. Let's change the FICO to be not 600, but let's make it, I don't know, let's make it 700 or something, right? That's again greater than the base level. So what's going to happen here is the FICO score, is that greater than the base level? Yes, right, because 700 is greater than the base level. However, once we jump down to this bit of logic here, when you test this expression, is 700 greater than the 850? No, since it's not, what's going to happen here is that the execution is going to jump down to line 16 and they're going to be assigned the gold rate. Let me rebuild this and execute it. No error. So in this case here, the interest rate should be the 5%, right, which is the gold rate. So if you have a 700 FICO score, then you get the 5%. Let me now bump this up to be 900. We can, and again, 850 or greater. Right? So if I just make this 900, then what's going to happen is 900 greater than the base level? Yes, it is, right? Because 900 is greater than 650. Then we're going to jump down into here. We're going to test, is 900 greater than or equal to the platinum level, which is the 850? In that case here, again, that's going to evaluate to true. So we're going to assign the platinum rate, okay, to my rate, which will be the best rate, which is a 4%. So I execute this, control F5. Right now they get the 4%. So that's how we can use nested if statements to execute more than one branch of logic. In a little bit, you'll see, actually, the next section, we're going to talk about if-else statements, and you'll see that it kind of clears things up a little bit. If statements, excuse me, and it makes things a little bit simpler in general. One thing I want to mention real quick before I move on is you need to make sure that within your logic you don't make any errors on what's called the boundaries. So here when I'm checking for if my FICO is greater than or equal to the base level, right? Greater than or equal to is going to include the 650, okay? Make sure if that's what you're trying to do, okay, then greater than or equal to is what I want to use here. Had I not used greater than or equal to, what if I just used the greater than symbol? Well, that would mean that I would be testing for anything greater than 650, which would be, again, assuming that FICO scores are integers. Well, in this case here, it would have to be an integer. It would be 651 or better. So you need to just make sure that you don't miss anything at the boundaries. So again, the idea is that there's a subtle difference between greater than or equal to and greater than, and less than or equal to and less than. So just be aware of that as you're creating your programs. In this example here, if I really wanted to test all of the branches of execution, and this is if we had plenty of unlimited time, this is what I would do: is I would test, a FICO score less than 650. I would test when somebody has a FICO score at exactly 650. I would test when somebody has a FICO score between 650 and 850, and then a FICO score at exactly at 850, and then another FICO score at something greater than 850, just to make sure that we test all the different possible branches of execution. The next step of conditional logic that we're going to take a look at is what's called the if-else-if statement. And in general, it typically will make your life a lot easier in the event that you need to create complex conditional statements and where you don't want to create a lot of nested if statements. It generally makes your code easier to read. And we're going to take the example that we just did with the FICO scores. We're going to take the example that we just did with the FICO scores and convert that to be an if statement, and you'll see it's going to make things look quite a bit cleaner. And here's a general, and this is out of your book. I believe this is page 176 or 177. And here's how it works. So we have the same thing as before. So we have if expression. So if this thing evaluates to true, this stuff in here will execute, and nothing else will execute. If this works out to be false, then we jump down to the next statement here, which is else if, and then we do another test on expression 2. If this works out to be true, then what we'll do is we'll go ahead and execute this stuff here, but nothing after that. And what we can do is we can create many more of these if, else if, else if, else if, else if statements as we want. And as soon as we find the first one that evaluates to true, that one will execute, and everything else will be ignored or not executed. And at the very end, there is an optional what's called a trailing else statement, meaning that if every statement before or every condition before it evaluated to false, then the final else statement will be executed. Technically, the else it's called a trailing else. Technically, this is optional, but most of the time you'll want to use this, and it's a good way to catch basically everything else or any kind of error that somebody might generate. So that's how the if-else-if works. So again, let's go back to the example that we just had before, and I just want to emphasize again that where it says else if right here, you can have many of these. Okay, in this example we have one if, then we have one else if, and then finally one else. We could have many else ifs. The only rule is that as soon as you have one if statement and you have another else if, you have to have an else if paired with the first if statement, and then after that everything would just be else if, else if, else if, and then finally else. So let's go back to my example that I was just working on over here, and I'm going to simplify this quite a bit. So I'm going to create, I'm going to use the same levels. I'm not going to change anything there, but what I'm going to do is change it to be an if statement, and you'll see that it does make things a little bit easier to read. All right. So the first thing we do is we're going to test to see if, instead of it being greater than the base level, what we're going to do is we're going to check to see if the person has a really good FICO score, meaning that it's greater than the platinum level. Then what we're going to do, and I can just use the delete key here. Then I'm going to just go into here and change this to be, just nest this or indent it properly. Then they're going to get the platinum rate. If their FICO score is not greater than the platinum level, then we're going to do an else if. We're going to say else if, and here I have to do a little test, and then we're going to check to see if my FICO is greater than or equal to the gold level. Oh, I need to create another level. I missed that step. Sorry. We need to create an additional level here. Let me put that between the base level and the platinum level, and we'll just call this the gold level, and I'll make this the, let's see what level I want to make this. So we'll do 650. Well, you know, let's just do this. Let's simplify this. All right. Let's just call this the gold level. Okay. The idea is that if you get something less than 650, you're going to get the base rate. If you get something greater than 650 but less than 850, that's going to be the gold level. If you get something greater than 850, then you're going to get the platinum level. So these will be the two levels that we're going to test against. Again, I just changed it to gold level only because I think it makes it a little bit more self-documenting. And now what I'm going to do is let me just bring this over to here, nest things nicely, else if, and then finally we have our last else statement. Okay. And it's going to look like this. So here's how the logic works in this program. So if my FICO score is greater than the platinum level, then they're going to get the platinum rate. Nothing else will execute. Execution stops there. The next thing that will execute would actually be the cout statement. Next time we run our program, if the FICO score is not greater than the platinum level, but let's say it's greater than the gold level, right? So let's say my FICO score coming in is, I don't know, 700. So this would evaluate the false, right? Because 700 is not greater than the 850. We would jump down into here, our else if statement, and we'd check is 700 greater than the 650? Yes, it is, right? So since that is true, this will execute. Okay, so we'll assign the person the gold rate, but this won't execute. Okay, because once one of these things evaluates the true, we'll execute the branch of logic which is within that expression, but then nothing else gets evaluated. Let's imagine the last time around we run this program and they come in with a FICO score of 600. Well, here we do a test. Is 600 greater than the platinum level? No, so this won't execute. Is 600 greater than the gold level? No, so that won't execute. Since this is false and this is false, all right, the very last thing that will execute, and this is guaranteed to execute, is what's called our trailing else. And here we just assign the rate of we just assign the silver rate to my rate. So let's try this with a couple examples. Let's work from the top down. So let's create the FICO. Let's see the FICO score rate is right now at 900. So if we leave it at 900, that should be the 4% rate. So let's build this thing, no errors, right? So if I build it, now you can see with the FICO score of 900, they get the platinum rate, which is a 4%. Let me change to be the 700. Right, we'll make this 700. If this is 700, what's going to happen here is that they're going to get the gold rate, which will be the 5%. So that's how you get the gold rate. And last time around, let's assume the FICO score is, let's make 100, whatever it is, right? So if it's 100, line 11 will evaluate to false. Line 14 will evaluate to false. Since there's no other conditions to execute, finally, the trailing else will execute, which is going to cause execution on line number 18 to execute, which would mean that they're going to get the default or the trailing else, which is going to be the silver rate, which is what, the 6%. So they get the 6% there. So that's, in summary, that's how we can use if statements, nested if statements, and if, else if, else if, else if, else statements. Play around with these. Try a couple of examples in the book. The example that's on page 1, it's probably 177 in your textbook, which is program 4-13, shows you an example where they're creating they're using test scores to assign a grade to like a student. And there's an example here where there's multiple else if statements, and I think it highlights very well how to use this type of decision structure for multiple branches of conditional logic without using nested if statements. So again, nested if statements are great for simple conditions. Once you have, I'd say 3 or more branches, I would recommend that you use an if else structure, because it just makes it easier on you. All right, in this section, what we're going to do is we're going to take expressions one step further. And quite often what you'll need to do is have multiple expressions evaluated within one statement. And the idea works something like this. It's, you might have some logic where, you're doing some kind of payroll application, and, if somebody's been employed for more than 5 years and had sales of greater than $10,000, they get some kind of bonus. So in that case there, they need to work, have worked more than so many years and have generated such amount of volume in sales in order to get a bonus. Another idea might be something like this. If a student has 0 absences and their grade is B or greater, then give them an extra couple points for extra credit or something like that. So the idea is that you might have multiple expressions that you want to what's called chain together, and treat them as one expression. And the way that we do that is using one of 3 different logical operators. And they're on what you see, they're on the screen right here, and it's the and, the or, and the not operator. So the and operator is a pair of double ampersands, the or operator is a double pipes, and the not operator is just the exclamation point. So the and operator, what it'll do is it'll connect 2 conditions, and 2 or more expressions, and it'll evaluate to true if all of those expressions evaluate to true. An OR operator does the same type of thing, but with the OR operator, you don't have to, only one expression has to be true in order for the entire evaluation to be true. And the not operator just reverses or negates an expression. Actually, it might sound a little bit strange to have something called a not operator, but believe it or not, it's used quite frequently. So let's take a look at how we would sort of use these guys, or let's first take a look at their rules, all right? Then I'll show you how we can apply one. All right. So if we're using the AND operator, in order for the AND operator to evaluate to true, both of the expressions on each side of the AND operator need to evaluate to true in order for that expression to evaluate to true. So if you have an expression that evaluates to true and another expression that evaluates to false, the combination of these 2 guys together will equal false. Same thing here on this line. Here, if we have 2 false statements, the evaluation is going to be false. The only way that the AND operator will return true is if on both sides of the AND operator, both of those expressions that will evaluate to true. If they do, then the evaluation of the expression will be equal to true or 1. Let's take a quick look at the OR operator. OR operator, here we go. OR. Hopefully there's a little table here. All right. The OR operator is a little bit different. All right, the OR operator, as long as one or both of the expressions on both sides of the OR operator are true, then the value of the expression will be equal to true. So if you have true or false, that evaluates to true. False or true, that evaluates to true. False or false, right? In this case here, both expressions are false, so the evaluation of the entire expression itself is equal to false. And here, if you have true or true, that evaluates to true. So with the OR operator, the only way that an expression will evaluate to false is if in fact both expressions evaluate to false. little bit different than the AND operator. And the NOT operator is quite simple. It just negates, okay, the value of the expression. So if you have an expression that's true, if you say not true, well, the value of the expression is then going to be false. If you have an expression that's false, if you say not false, well, then the evaluation of the expression is true. So let's go back to our little program that we have over here, and let me change just a little bit. And here I'm going to apply another rule, and I'm going to say, all right, if somebody has good credit, meaning that they have, they are either at or above the gold level. So if they have good credit and they're employed, then what we're going to do is we're going to reduce their interest rate by 0.5%. All right. So again, so in this example here, the rule is going to be testing two different things, right? So they both need to have a good credit and they need to be employed. If they meet both of those criteria, then they're going to get a reduction in their interest rate. So what I'm going to do is I'm going to keep all these calculations the same. So from lines 11 through 19, they're going to leave that all the same. And now what I'm going to do is let me create another variable here, and I'm going to call this I'll have a little flag here, bool employed, and I'm going to assign that the value true. Again, imagine this is coming in from some payroll system, what have you, and you're getting, some indication as to whether or not somebody's employed, maybe full-time or part-time or whatever it is. Let me also change your FICO score here to be, I'm going to bump it above the gold level, so I'll make it 700. So in this case here, based upon the criteria, right, the person has a good FICO score and they're employed, so they should get a reduction in their interest rate. So what we're going to do is down here, after our if else statement, we're going to do a little test. All right, so here I'm going to test for those two conditions. So here I'm going to say if, all right, and I'm going to wrap these guys in parentheses just to make it a little bit easier to read, and it's probably going to be easier for you to read also if you continue this this type of formatting going forward. So what's the first rule? So the first rule is that they have to have a good FICO score. My FICO, so if my FICO is greater than or equal to the gold level, right? So this is one expression here, right? So we're going to see if this and something else is true. So if they have a good FICO score, and then after this, in between these parentheses, I'm going to say double ampersand. I believe you can't have any white space in between. Just keep them together. Right? If we did this, I think that would be a compiler error. Maybe not, but just for consistency purposes, I would just leave them together. So that's the first criteria, and let's, within parentheses, evaluate the next criteria, which would have to be that they need to be employed. So employed has to be equal to true. All right. All right. So that would be the AND condition that we're going to use. And let me just then go ahead and give them the reduction in their interest rate. So the idea is that if they get a good FICO score, if they have a good FICO score and they're employed, what we're going to do is we're going to give them a reduction in their interest rate, and we're just going to say my rate. I'll use a shortcut here, right? We saw this before, the compound operators. We're going to say my rate minus equals 0.5%, which would be 0.005. And then we'll just do a little cout here, and we'll just say congratulations, something, blah, blah, blah. Cout. Congratulations, your rate is reduced by, and we'll just so you can see this executes. Again, this is probably something that you want to use in a constant, but try to keep it simple right now. All right. So if this is true and this is true, then they get the reduction in my rate. Had I changed this to be like the OR operator, only one of these two items would have to be true in order for this expression to evaluate to true. So just go through the book real quick later on and double check to make sure you fully understand how AND and OR works. Again, you could have multiple AND conditions. You could use multiple AND logic operators. So I could have other tests over here. If my FICO is greater than or equal to the gold level, and they're employed, and they're employed, more than 5 years at their current job, then they get a reduction. Okay, so you could string a bunch of these guys together. So let me just build this the way it is. And if I do that, this person should get a reduction in their interest rate because they have a good credit score and they're employed. So let's run this thing. So it says, congratulations, your rate is reduced by, half of 1%. And now instead of you getting just the gold rate, which would be the 5%, you're actually getting 4.5% because you fell within that 700 level. Let's test this for another one of the options. Let's change our FICO score to be the 900, which would mean that their interest rate should then get bumped down to 3.5%, right? Because they're employed and they met that threshold. So in this case here, they're employed and they are getting their interest rate reduced by 0.5%, right? Because their FICO score is good and their rate gets reduced to 3.5%. Let's leave employed the way it is, and now let me bump down their FICO score to be 600. All right. So with the FICO score is 600, what's going to happen is once we get down to line number 22, this is going to evaluate the false, right? Because the FICO score is not greater than a gold level, right? So this is going to evaluate the false. So since false and true, it's going to evaluate the false. This won't, lines 23 and lines 24 will not execute. So let's run this again. No compile errors. And now you'll see that your FICO score of 600, which is not the good score, all right, will not reduce your interest rate. So now you're at the 6%. So that's how logical operators work. Play around with these. It's really good to understand how AND OR works. You'll see the NOT operator used, and I'll use that in some examples later on down the road. But for the time being, I think if you just could get comfortable with using AND and OR, that would be sufficient. Another common use of the AND and OR operator is to check for numeric ranges with your AND and OR logical operators. And the idea works something like this. Imagine you're creating a program, maybe not necessarily for a computer or a PC or a Mac or something, but maybe some other kind of hardware. And you need to check if something is within a particular operating temperature in order for the device to be used. And then actually, I think even like my iPhone does this, right? If it gets too hot, the thing will spit out an error message. Like if you leave it on your dashboard, and then it'll say that temperature's too hot, blah blah blah. Let it cool before you use it. So the best way to do something like that is to check if something is within a particular range is to use the logical AND operator. So let's imagine I have two values here. I don't know. Let's just keep this simple for now. Let's say that int, just say temp is equal to 50. All right. So imagine that there's some sensor that's reading a temperature, and the sensor is reading the value 50. And let's imagine that you want to check for, let's say int. Let's make these constants. Const int low is equal to 10. So it has to be greater than 10, and high is equal to 120. So the idea is that the temperature has to be within an acceptable range, okay? And if we want to check for it to see if a value is between or within a particular range, it's easiest to use the AND operator. So let me show you how we could do something like this. So here I could say if, and let me wrap these in a pair of parentheses. I'm just going to say if temp is greater than or equal to low, and right, I want to test that temp is less than or equal to high, not height, excuse me, I have a typo, less than or equal to high. All right, then I could say, a capture, so I'll just say temp is okay. Temp is okay. So if, again, by using the AND operator, right, the temperature has to be greater than or equal to low, and it has to be less than or equal to high. So this is where I'm testing for a range, okay, within a range. You know what? Let's just do this. Let's create an else, and let me just copy this down. I'll just say temp is, right, just to show you how this works, not okay. So in this case here, 50 is within the acceptable range, so we would allow the device to continue. Temperature is okay. That's good. Let me change the temperature now to be, I don't know, 130, right? Left your phone on the dashboard and got a little too hot. Well, now temperature is not going to fall within the range of the expression on line 9. So the else statement on line 11 will execute, which will cause the statement on line 12 to be executed. So meaning the temperature is not okay. So that's how you check for if a value is within a range. What if you want to check for a value that is outside of a range? Well, then you would want to use the logical OR operator. So let me reverse this a little bit. Let me put my let me leave my temperature at 130 still, and I'm going to change this expression here to be 4. Okay, and let me let's do this. Let me check to see if temperature is, right. So if my temperature is less than low, or my temperature is greater than high, okay, that would mean that the temperature is not okay, because either it's too low or it's too high. So this would say temperature not okay, and then this would mean that the temperature is okay. So I'm really performing the same thing. I just kind of reverse my logic a little bit, right? So here I'm not checking for within a range, but I'm checking outside of a range. In this case here, 130 would fall outside of the range. So here if I say is temperature less than low? No, because this is false, right? Because 130 is not less than 10. However, this is true because temp, right, 130 is in fact greater than high. So since I have a false or a true, the evaluation of this entire expression will be true, and this would tell me that the temperature is not okay. So if I execute this, right, it says temperature is not okay. If I change my temperature now to be, I don't know, what was it before, 50? If it's 50, then I would come down here, right? Is 50 less than low? No, this is false, right? Because 50 is not less than 10. Is 50 greater than high? No, this is false, right? Because 50 is less than 120. So line 10 wouldn't execute, but instead line 12 would execute because the temperature falls outside of that range. So if I execute this now, it should tell me that the temperature is okay. So just be aware of that, right? So both of them will do the same thing if you code them properly, but it's generally best to use, and it's best to use the AND operator, check for values within a range, and it's good to use the OR operator to check for values that are outside of your range. Right, the last thing I'm going to cover for this lesson is going to be the what's called the switch statement. This is something you'll see in a lot of other programming languages such as Java. Visual Basic even has a similar mechanism. And what the switch statement allows you to do is to create a conditional branch based upon the value of an expression, or a single value within an expression. And it's typically used as a substitute or in place of an if statement. And the construct looks like this. And again, this is out of your book around page 203. So the way that works is we have what's called the switch keyword. After the switch keyword, within parentheses, is an integer expression. Okay, this can be something that is either one of the integer types, or even commonly uses a character type. Down below, within the curly braces, you have your corresponding case statements, and you would have typically, more than one, 2 or more case statements, and then perhaps a default statement. And the way that this works is based upon the value of the integer expression, one of the corresponding case statements will execute, If none of the case statements match the value in this integer expression, then what happens is the default statement will execute. So let's take a look at a little example. What I'm going to do is I'm going to create a little program, and hopefully I can get this done in about 15 minutes or so, which will allow the user to see like a little menu and allow them to choose based upon their input whether you want to convert a value from Fahrenheit to Celsius or Celsius to Fahrenheit, something along those lines. Let me go back to my program here. Let me get rid of what we have in here. So let me kill all this stuff. All right, so what we're going to do is I'm going to display something that's going to look like something that's going to be a little menu, and what we're going to do is capture the user's input and then convert their input to either Celsius or Fahrenheit. So I need to create a couple variables up front, both to capture the user's selection and also to capture the values of Celsius and or Fahrenheit, depending upon what conversion we're doing. So I'm going to create my first variable here is going to be the integer. I'm going to call it selection. And then I'm going to have another set of variables here for Fahrenheit. I think that's how you spell Fahrenheit. And then Celsius. All right, so we're all set there. Now what I'm going to do is I'm going to create a little menu. So I'm just going to say cout. Select an option from below. And here's where we're going to actually display the menus. So I'm going to do cout, and if they select the number 1, okay, this is where we're going to convert from Fahrenheit to Celsius, or F to C. If they, I'm going to steal this and copy it down. If they choose option 2, we're going to do the opposite. We're going to convert from Celsius to Fahrenheit. If they choose option 3, we're going to exit the program. And then let's just have a little output here which just says, enter your selection. Enter your selection. And let me get rid of the end out here. That won't be needed. Now we're going to capture the user's input. No different than we've done before. So I'm going to say cin into selection. All right. Now what happens is the user is going to have the ability to enter the value 1, 2, or 3, or to be honest with you, they could enter any value on a keyboard. We're just going to capture the values 1, 2, or 3. And what I could do is I could create a little if statement where I say, if the selection is equal to 1, convert from Fahrenheit to Celsius. Else, if the selection is equal to 2, convert from Celsius to Fahrenheit. Else, exit the program, something along those lines. But in this case here, what I'm going to do is I'm going to create a switch statement. Switch. So this is my keyword. Open parenthesis, and this is going to be the value that we're going to switch on. And selection. Let me just close this off here, just so you can see. Selection has to be either a literal value, okay, or an integer value. Okay, so if I had switch selection, if I wanted a hard-coded value in here, I could. Not such a good idea. It kind of defeats the purpose. But whatever the value is for selection, it must be some kind of integer expression. And then below, what we're going to do is we're going to have a set of corresponding what's called case statements. So I'm going to say case, and if they enter the selection 1, and here's where we're going to put a colon, one of the very few places in the C++ programming language where we're going to see a colon used. So if they choose case 1, I'm going to indent this a little bit, just I think it'll be a little bit easier to see. And here we're going to have a little prompt again. We're going to say cout, oh, please enter the temperature in, I'll just say capital F for Fahrenheit. Right, so we're going to prompt the user for that. Then we're going to capture the user's input. So I'm going to say C. Oops, got my endl, my semicolon. Then what we're going to do is we're going to capture the user's input, and we're going to capture this into the variable Fahrenheit. Now what we're going to do is we're going to convert Fahrenheit to Celsius. So I'm just going to say Celsius is equal to, and this is the formula, and you don't need to. You can look this up. This is a simple thing to do. So it's Fahrenheit minus 32 divided by Fahrenheit divided by 32 times 5.0 divided by 9.0. Why am I doing 5.0 divided by 9.0? Because I don't want to do integer division. I want to do double division. Right. So that will be the end of my calculation there. Then I'm going to say, okay, see out Fahrenheit. So that many degrees F Fahrenheit equals Celsius and then we're going to have a following break statement here. All right. So what is this going to do? So if somebody enters the option 1, we're going to break onto this line of code on 17, case 1. We're going to prompt the user to enter the temperature in Fahrenheit. We're going to capture the user's input. We're going to convert Fahrenheit to Celsius. And then we're just going to display what some degree Fahrenheit is equal to in Celsius. So we'll just display the conversion. I think the format looks like it should be okay. We'll see. Again, this section is not about formatting, but it's about case statements. What if somebody enters another option, case 2? Well, you know what we're going to do? I'm going to copy this down because I can reuse a lot of this. So let me copy this down. Oh, by the way, once these lines of code execute, the break statement on line 22 will cause your program to no longer execute any code within the switch statement. So it's basically just like sort of like a ending curly brace. You can think about it that way. So let me do the other option for case 2. Again, I'm going to copy and paste this down because I'm going to steal a lot of this stuff here. So case 2, I'm going to say please enter the temperature in Celsius. So I'm going to capture Celsius. We capture the value in there. Celsius conversion of Fahrenheit is equal to it's Celsius times 9 divided by 5. 9 divided by 5. Why am I using parentheses here? To follow the order of operations. Plus 32 degrees. That should work. Now what I'm going to do is change this to be Celsius. Fahrenheit. F. Alright. So now if somebody answers option 2, lines 17 to 22 won't execute. However, lines 24 through 28 will execute. Now we're going to do the complement, right? So we're going to convert from Celsius to Fahrenheit. I think I got the formula right there. I'll test it in a little bit. If not, I'll go back and fix it. Now, if somebody enters the third option, which is case 3, what do we want to do here? We want to exit out of the program. The way that we exit out of the program, there's a method that's called exit. And we can give it a return code. Typically give it a return code of 0 for successful execution. And then we're going to break once again. So that's the end of my third case. What if somebody enters something other than 1, 2, or 3? Then what we're going to do is we're going to capture what's called the default statement. So this is just DEF, a default. And here, okay, we're just going to have a little prompt that just says cout is not a valid selection. The default statement, just so you know, is optional. I want to put it here to capture the case where somebody enters something other than 1, 2, or 3. And if they do, we're just going to display a little error message that would say, this is, that selection is not valid. We would probably want to change our program, but we haven't gotten this far yet to do something where if the user keeps entering an invalid selection, we'll just keep prompting them over and over again until they do enter something valid, and then perform the valid steps. So what's going to happen here is here's the beginning of my switch statement. Here is the end of my switch statement. All right. One of these 3 paths of execution are going to execute, but not any more than one. Now, if I run my program here, one other thing I want to mention real quick too. This is important. Within switch, this expression here can be either a literal value or any kind of integer variable type, meaning anything that's like a short or an int or a character data type. These values that come after the case statement, those have to be a integer literal or a constant. They cannot be your typical variable, so it either needs to be a literal, such as a number 1, or a constant variable. Okay, it cannot be a regular, read-write variable. If you do that, you'll get a compiler error. So anyway, let me run my program here. Let's see how this looks. If I need to make any changes, we'll jump in here. Good, no errors. So select an option from below. So I want to convert from Fahrenheit to Celsius or Celsius to Fahrenheit or exit. So let me enter a prompt. So let's do 212 Fahrenheit. For what I remember is 100 degrees Celsius. So if I do that, I'm sorry. Please enter your selection. I made a mistake. All right. Please enter your selection. So my selection is going to be option 1. Once I select option 1, execution will jump down to line number 17, and we have a match. All right, so I entered 1, we have a match on 1, and now I'm breaking on line 18 where it's asking for me to enter a temperature in Fahrenheit. So now I'm going to enter the temperature in Fahrenheit, which is 212. 212 will then be captured. We'll convert it to Celsius, and then we will display what 200 degrees Fahrenheit is equal to 100 degrees Celsius, and then my program terminates. Let me run this again for option 2. So if I run option 2 here, enter your selection. So if I select option 2, enter the temperature in Celsius. So if I do 100 Celsius, right, that should be 212 degrees Fahrenheit, right? Oh, I got an error. Let's see what my error is. So I entered 100. Where did I break? So please enter your temperature in Celsius. Celsius. 9 divided by 5. This is what I did wrong. I didn't capture the value. This is a common mistake when you do copy paste. So what happens is I declared a variable up above. All right, I declared Fahrenheit up here. I never assigned it a value. Over here on line 27, what I'm trying to do is use the variable Fahrenheit. However, I never initialized it with a variable, so I'm getting a runtime exception in debug mode. So what I need to do over here is capture Fahrenheit. I'm assigning everything to the right of equal sign to Fahrenheit. So if I do this now, that should work. Let's try it again with option 2. So if I select option 2, please enter temperature in Celsius, 100. 100 Celsius, 212 degrees Fahrenheit. And let's try it with option 3. So if I enter selection 3, selection 3 should jump down to the case statement on line number 29. Once I do that, the only thing that we're going to execute is the exit function on line 30, and that will terminate my program. And you already saw earlier what happens is, what if I enter something that's not 1, 2, or 3? In this case here, I remember originally I did 212. So let's say I enter number 4 or something, right? If I enter the value number 4, that will cause my program to not match any of the case statements. So the default statement is the one that's going to be caught. Okay, and this is going to trap that input, and the CAT statement on line number 33 will be the only bit of code that executes. So I hit enter. It says right 4 is not a valid selection. Again, typically what you do is you just prompt the user again to display the menu and be done. So that pretty much wraps it up. Not for this entire chapter. I wanted to try to keep this underneath an hour, and I pretty much nailed it right now. I covered enough of the material here for you guys to work on both the lab that I'm going to assign, the midterm multiple choice exam, and also the midterm lab. So you have enough material to do that in terms of our lessons. And there's, I don't know, maybe 2 or 3 little sections in chapter 4 that I will revisit once we come back from break after the midterm. They're important sections. I don't want you to skip over them, and I want to finish them before we move on to chapter 5. So anyway, that's it for this week. See you. Bye-bye.